Dear students, we shall now solve if y equal to x plus square root of 1 plus x squared the whole power m. Then we have to prove that 1 plus x squared multiplied with y n plus 2n plus 1 multiplied with x y n plus 1 plus n squared minus m squared multiplied with y n equal to 0. Now this problem is a very important problem which has appeared in many question papers. So we shall solve this problem now. So first, what is given to us that we have to write. So it is given that y is equal to x plus square root of 1 plus x squared the whole power m. So now first we have to find y1. That is, we have to differentiate y with respect to x on both the sides. So when we differentiate y with respect to x, we get y1. So y1 is equal to, now we have to differentiate this whole term with respect to x. So it will be m multiplied with x plus square root of 1 plus x squared the whole power m minus 1 multiplied with, we have to do the chain rule here. The differentiation for x is 1 plus, now we have to differentiate square root of 1 plus x squared. That is, square root of 1 plus x squared, actually it can be written as 1 plus x squared the whole power 1 by 2. Now what is the differentiation of this? This will be 1 by 2 multiplied with 1 plus x squared the whole power 1 by 2 minus 1 multiplied with the differentiation of 1 is 0 and the differentiation of x squared is 2x. So actually this is 1 by 2 1 plus x squared the whole power. Now 1 by 2 minus 1 is minus 1 by 2 multiplied with 2x. So this 2 and this 2 will get cancelled, and this 1 plus x squared is raised to the power of minus 1 by 2. So when it comes to the denominator, it will become 1 by 1 plus x squared power 1 by 2. That power 1 by 2 can actually be written as square root of. So square root of 1 by square root of 1 plus x squared multiplied with x. So this is what we obtain. So this is x divided by square root of 1 plus x squared. So we shall substitute that here. So differentiation of square root of 1 plus x squared we have found here. So if we substitute that here, we get x divided by square root of 1 plus x squared. Now after this, y1 will be equal to m multiplied with x plus square root of 1 plus x squared the whole power m minus 1 multiplied with, now here we can take LCM. So once we take LCM, it will be square root of 1 plus x squared, and we have to multiply this with 1. So we will be getting square root of 1 plus x squared plus x. Now we can bring this square root of 1 plus x squared, which is in the denominator, to the left hand side by cross multiplying it along with y1. So this gets multiplied with y1 and it becomes square root of 1 plus x squared multiplied with y1 equal to m multiplied with, now if you see here, we have x plus square root of 1 plus x squared the whole power m minus 1, and this is also the same only, x plus square root of 1 plus x squared. So the powers can be added for this. So here the power is m minus 1 and here the power is 1. So the powers, when it is added, it will become m minus 1 plus 1, which will be m. So this will be x plus square root of 1 plus x squared, and then the powers is m minus 1 plus 1, which will be m. So now after this, if we see, what is this term actually? It is our given y, because it is given that y is equal to x plus square root of 1 plus x squared the whole power m. So here also we have x plus square root of 1 plus x squared the whole power m. So this term can be replaced and it can be written as y. And so this becomes square root of 1 plus x squared y1 is equal to m multiplied with, now this term is y. So m multiplied with y. Now we have to get rid of this square root. So we have to multiply both, we have to take the square on both the sides. So squaring on both the sides. What do we get? Now when we square this term, it will be square of the square root. And so we will have the term only. And then we have to take the square of y1, which will be y1 squared, equal to the square of this term is squaring m, we get m squared, and square of y is y squared. Now we shall differentiate this again with respect to x. So differentiating again with respect to x. Now we have to use uv method, where this will be treated as u and this will be treated as v. Now this term, when we differentiate, we get so 1 plus x squared. First this has to remain as constant and we have to differentiate y1 squared. The differentiation for y1 squared is 2y1, and then again we have to use chain rule and we have to differentiate y1. The differentiation of y1 is y2 plus, now y1 squared will remain, and then the differentiation of 1 plus x squared. The differentiation of 1 is 0 and the differentiation of x squared is 2x is equal to, on the right, m squared is a constant multiplied with the differentiation of y squared. The differentiation of y squared is 2y, and then again we have to use the chain rule and differentiate y, whose differentiation is y1. Yes. Now if we see, we could see that the term 2y1 is common in all the three terms. So here also we have, and here 2y1. So we shall divide by 2y1 on both the sides. So dividing by 2y1 on both the sides. What do we get? 1 plus x squared multiplied with y2, and then plus and here 2y1 will go, so we will have x and 1 y1. So x y1 is equal to, here also 2y1 will go away, so we will have m squared y left out, so m squared y. Now we will bring this m squared y to the left hand side. So what will happen to this term is, it will become 1 plus x squared y2 plus x y1 minus m squared y is equal to 0. Now we have to apply nth derivative on both the sides. So nth derivative on both the sides. So when we take the nth derivative on both the sides, what do we get? The nth derivative of the first term. So 1 plus x squared y2 plus the nth derivative of the second term xy1, and then minus nth derivative of the third term, which is m squared y is equal to 0. Now what we will do, let us mark this as Roman letter 1, and we will treat each term, this term as 1, this is term 2, and this is term 3. And we will find the nth derivative of each term separately and then bring and substitute in this equation, and then we will simplify it. So let us see how to do that now. So now first let us find the nth derivative of 1 plus x squared multiplied with y2. So for this we have to use the Leibnitz formula, which is given by nth derivative of uv. So this is in the form of uv, where this term has to be taken as u and this will be taken as v. So always remember, the term u will be the variable y and the term v will be the variable x. Okay, so now we will be choosing u as this and v as this, and we have to apply in this formula. So let us do that now. So first what we have to do, we have to take v to be equal to 1 plus x squared. Then we have to find v1. So v1 will be, the differentiation of 1 is 0 and the differentiation of x squared is 2x. Then we have to find v2, which is equal to the differentiation of 2x. So differentiation of x is 1. So 2 is a constant. So 2 into 1, which will be 2. Next, the differentiation of 2, which is equal to, which is a constant. So it is 0. So once we attain 0, we have to stop differentiating further. Then u will be equal to this y2. Now, first we have to find un. So un is equal to the nth derivative of y2. So what we have to do, we have to add this n and 2 and we have to write it as y n plus 2, because already y is differentiated 2 times, and when we differentiate it for the nth time, then it will become y n plus 2. So that is what I have said here. You can also remember in this way. You have to add this and you have to write it here. Next we have to find un minus 1. So un minus 1 is equal to n minus 1th derivative of y2. Now again adding this and this, n minus 1, it will become y n minus 1 plus 2. But what is that? So y of minus 1 plus 2 is 1. So it will become n plus 1. And then we have to find y un minus 2. So un minus 2 is equal to n minus 2th derivative of y2. So that is equal to y, adding this and this, n minus 2 plus 2. So it will be equal to yn, because minus 2 plus 2 will get cancelled. So once you attain yn, we have to stop differentiating this further. And now we have to substitute these two in the formula. So the nth derivative of, so now we will find this, that is the nth derivative of 1 plus x squared y2. So when we apply it in this formula, it will be equal to, first is nc naught. So we have to write nc naught. Then we are having un. Un is what? Yn plus 2. So it is yn plus 2. Then v. So v is 1 plus x squared. Then plus nc1. After writing nc1, what is un minus 1? Un minus 1 is yn plus 1. So this one. So it will be yn plus 1. And then we have v1. What is v1? v1 is 2x. So it will be 2x plus, I will write that term here, plus nc2. Then what are we having? un minus 2. Un minus 2 is yn. So it will be yn multiplied with v2. v2 is 2. So after this we have to stop it, because v3 is becoming 0, and so the next further terms will all be 0. So we have to stop here. Now we will simplify this. So this will be equal to the value of nc naught. The value of nc naught is equal to 1. And then the value of nc1 is equal to n. So value of nc1 is equal to n. And then we have the value of nc2. So the value of nc2 is equal to n into n minus 1 divided by 2. So you have to remember all these three values and substitute here. And so when we substitute nc naught as 1, we get this term to be 1 plus x squared yn plus 2. And then the value of nc1 is n. So this term will become plus 2. This constant will come in the front. This is n x y n plus 1. Plus nc2 is n into n minus 1 divided by 2. And then yn multiplied with 2. This 2 and this 2 will get cancelled. And finally we will have this term as 1 plus x squared yn plus 2 plus 2nx yn plus 1, and then plus n into n minus 1 can be written as n squared minus n, and when that gets multiplied with yn, it will become n squared yn minus nyn. So this is our equation 1. So we have, term 1. So the first term we have found. Next, similarly, we have to find the second term. So next we have to find the term 2. We have found this now. Now we have to find nth derivative of xy1. So let us do that now. So nth derivative of xy1 will be equal to. Now here again we have to make the selections. So what will be our u and v? So v will be equal to this x, and our u will be equal to y1. So first we have to find v1, which is equal to 1, v2 which is equal to 0. So once we get 0, we have to stop doing this. Next, for un, it will be equal to the nth derivative of y1. So that is equal to y. We have to add these two terms and we have to write here. So it will be n plus 1. So similarly, next we have to find yn minus 1, which is equal to the n minus 1th derivative of y1. Now we have to add these two. So when we add n minus 1 plus 1, so minus 1 plus 1 will get cancelled and we get yn. So once we get yn, we have to stop this and we have to substitute in the formula. So when we substitute in the formula, the nth derivative of xy1 will be equal to, the first term is nc naught multiplied with this un. So what is un? Un is yn plus 1. So if you refer the formula, you will know. First term is nc naught un. So un is yn plus 1 multiplied with v. V is x. The second term is nc1 un minus 1. So un minus 1 is yn multiplied with v1. V1 is 1. And after that it will be 0 because v2 is 0. So when we substitute all that value, that term will become 0. So we have to stop till here. But what is nc naught? Already we saw that nc naught is 1 and nc1 is n. So when we substitute that here, this will become x yn plus 1. Because this is 1, it will be only x yn plus 1. And this is n, so we will have plus n y n. So let us mark this as term 2. Now we will find term 3. So what is term 3? Term 3 is nth derivative of m squared y, which is very simple. Because nth derivative of m squared y will be equal to, this m squared is a constant, so it will be m squared nth derivative of y. But what is nth derivative of y? It is yn. We all know that nth derivative of y is yn, and so this will be equal to m squared yn. So this is term 3. So we have found term 1, term 2 and term 3. So we will substitute all the 3 terms in this place. So now after substituting, that is in this place we have substituted this value which we have found, and in this place we have substituted the value that we have found, and this is minus m squared yn equal to 0. Now after this, if we check, we could see that minus nyn plus nyn will get cancelled, and these terms will become the 1 plus x squared yn plus 2. And if you see here, here you have yn plus 2 and here also you have yn plus 2. And what is common to these two terms? Xyn plus 1 is common. Xyn plus 1. So if we take that common out, we will be left out with 2n plus 1. So this will be 2n plus 1 multiplied with xyn plus 1. So these two terms are over now. Now the left out two terms is this. Now if you see here, yn is common, and so this term will become n squared minus m squared multiplied with yn equal to 0. So this is what we have to actually prove. So when we compare the question given, we see that we have proved that 1 plus x squared yn plus 2 plus 2n plus 1 xyn plus 1 plus n squared minus m squared yn equal to 0. So hence we have shown the required result. Hope you have understood this problem. Thank you.